Good afternoon and welcome to the second part of the Module 3 PISA Information System Audit course that deals with the system development life cycle, its implementation, maintenance. I hope you have seen my earlier part 1 and see the entire module itself is very exhaustive. So I thought of selecting few important concepts. I wanted to review with them. The part 1, we have done online auditing techniques. We have done testing in system development life cycle. We have spoken about check digit. We have talked about parity, checksum, and cyclic redundancy checks that are being used for authenticating the data during the transmission. Now onwards, I'll be talking about the project management techniques, the decision support system. Then as far as development methodologies are concerned, we'll be talking about Agile system development methodology, then object-oriented system development, prototyping, and rapid application development. So since the duration of these projects this video gets lengthy, so I will not discuss anything. Further, I'll just move on with the topic. Starting with Pert, CPM, Gantt Chart, FPA, EVA, time box. In these, we'll be talking first about program evaluation review technique. Now, Pert is a technique for estimating the project duration. Now, project characteristic is that it has a definite start and a definite end. They're not repetitive in nature, and there is a lot of commitment, irreversible commitment of resources in terms of money, men, and material for that completion of the project. So we are today talking about the project, specifically we are talking about the software development project. So various techniques are there used to estimate that how much time or how much duration is going to take for completing the project. So Pert is one of such technique which helps in estimating the project duration. So these red, again, I repeat in this video also, the lines which are repeated and the words which are repeated in, highlighted in red, they are taken exactly from the answers options that are being given in the PISA exam question. Now, Pert considers 3 different time estimates. That is optimistic, pessimistic, and most likely. Now, what happened is that when a project consists of activities, and these activities have a start time and end time. And we also have a time float in between. So these are basically 3 time floats which Pert considers when it tries to calculate, when it tries to estimate the project duration. Now, optimistic time is the best time that most likely an activity can take, will take this much amount of time and completely. That is the minimum possible time that an activity can take to complete, or you can say the best. Second is pessimistic, that is the worst likely. If everything goes wrong, then how much time an activity would like to take. And the third one is most likely, that is the normal, that is in everything when goes normal, everything is going on normal for the project, then how much duration this activity is going to take. So based on these 3 estimates, the project duration is being calculated using Pert technique. Now, Pert is more reliable than a critical path method for estimating project duration. That you should keep in mind. If in options you have the Pert as well as CPM also, select Pert. Now we move on to the critical path method. It is a technique for estimating, again, project duration. Now both are there. Pert is also estimating project duration. CPM is also doing it. All projects have at least one critical path, which means that you cannot have more than one critical path. Now, critical path is a sequence of activities where duration is the longest as compared to the other part. Now, which means that all the critical activities are falling on this path. Now, CPM represents the shortest possible time required for completing the project. Now, if you realize it has longest in the longest duration. Now, the longest duration, it has the shortest possible time. Activities on critical path have slack time equal to 0. Now, let's understand what is a slack time. We can say that all the activities with 0 slack time are on a critical path. Now, remember this in mind, that slack time is the amount of a time an activity can be delayed without impacting the completion date of the project. Now, suppose that 10 activities are involved, and out of these 10 activities, 5 activities having, there is a slack time for those activities. which simply means that even if these activities are delayed for something or some reason or the other, the entire completion duration of the or completion date of the project will not be affected. But in case if an activity has a zero slack time, which means that this is a very critical activity, and if you delay it or you change this activity or you postpone it, the completion duration of the project will be affected seriously, which simply means that any activity of a project activity, which is having a zero stack times, makes that activity very critical. And we have to focus on those activities so that we can reduce the overall project completion time. So now, critical path method, you should remember that there can be only one critical path. All the activities lying on the critical path will have certain slack time. If any activity is having a zero slack time, which means that you cannot ignore those activities, they are very critical to the completion of the project. Now, Gantt chart, that is, it helps in finding the progress of the entire project. Now see the difference. Pert and CPM talks about estimating the duration. It talks about the progress in the sense the milestones which are being achieved. So Gantt chart is also used for tracking the achievement of milestone. Now, milestone is the project consists of phases. So how many phases of the project have been completed, you can easily find out with the help of a Gantt chart. Then I have given you the answering preferences over here. When objective is to estimate project duration, give preference first to Pert and then to CPM. When object is to monitor the project or track any milestone, preference should be given to the Gantt chart. So that's the only thing you should remember about project estimation techniques. Similarly, there's another point called as function point analysis, because we were talking about the software project development. And then there is a called source line of code, SLOC. These are important in the sense because questions are directly framed onto it. Now, function point analysis is the indirect method of software size estimation. So normally project estimation in terms of when you are developing a software project, you're very concerned about deciding about estimating the size of the software, right? Now, size of the software depends on the types of modules and the type of functions and the type of connections you're going to use in the software. Now, function points are units measured for software size. Now, unit measure in the sense how many modules you will have, how many functions each module will have, how many modules will be connected, how the linkages are established between the modules. All these are basically your unit measures when it comes to function point. And you can say these are all your function points. Now, function point analysis is arrived on the basis of number and complexity of input, output, file, interfaces, and queries. I've discussed with you. So these are all basically that. Just remember that when you say function points, then you are talking about how many points will be functional points will be there in the software. And based on that, you're going to estimate the size of the project. Functional point analysis is more reliable than source line of code. Right. I mean, obviously, here you in function point analysis, you are talking about you're more concerned about the functions the software is going to perform in terms of input, output, files, and interfaces. Whereas in source line of code, you are more concerned with the you're talking about how many lines of source code is being used in the program. Now, it doesn't talk about the software functions. It only talks about the line of code. Now, these lines of code does not actually tell you the correct, you cannot arrive at a correct size of a software project based on this, because you can have multiple source line of code, which depends on the programmer. A smart programmer can reduce the source line of code, where a normal programmer can have same thing done in many numbers of lines. So this may increase the size of the software. So SLOC is a direct method of software size estimation because you can count the number of source line codes. So in both the options, if it is given for a size estimation of a software, please select function point analysis as this more reliable, though it is indirect, but it is more reliable as compared to source line of code. Now, earned value analysis compares metrics at a regular interval. Now, again, it is basically a technique of measuring the software. So it measures at regular interval budgets to date, that is, what was the budget and how much as on date it has been spent, actual spending on date, estimate to complete, and estimate at completion. Now, EVA compares the planned amount of work with actual work completed to determine if the cost, schedule, and work accomplished are progressing in accordance with the plan. Now, this is basically I'm trying to check through EV. I'm trying to check whether my project is adhering in terms of completion, in terms of budget, in terms of time, in terms of progress, in comparison to what is being planned. So I'm very concerned with what I have thought of when I was initiating the project and how the project is moving across the timeline in terms of monetary resources. So in a way, you can say that EVA is talking about the EVA uses metrics at regular intervals to compare the resources that are being consumed by what is being planned and what is actually completed. Time box management prevents a project cost overrun and delay from scheduled delivery. Now, this is again a technique which helps us in finding it out whether we are overrunning and delaying the project or not. Now, the question is sometimes it happens because projects, as I mentioned earlier, it consumes huge amount of irreversible resources in terms of men, money, and material. So which means that it has to be monitored and regulated at a regular interval of time. If you don't do that, then you, at the end of at the completion of the project, you may find that you have overrun in terms of cost, or if in time you may find that the project has been delayed in terms of the duration. Right? So this time box management is a technique which not only prevents project cost overrun, you find out as well as the delays also. The next is in time box management technique is quite relevant, and you may find a question on this. Now, it is used for prototyping or rapid application development, where projects are to be completed within the time frame. Now, I'll talk about rapid application development RAD later as I move onto that point. But here I'm trying to give an example that time box management is used when you are prototyping or you are going for a RAD when you are developing a project, because in rapid action development of software, you don't bother about documentation, you don't go about the formal structure. You simply develop a small prototype, implement it, find out what are the shortcomings, then again improve the prototype, implement it. When you are doing this type of work, in that case, time box management is very helpful in preventing the cost overruns as well as delays. Now, time box management integrates system and user acceptance testing, but does not eliminate the need for quality process. Right? Again, I'm saying, as we have discussed in the first part of this module 3, the time box, we have the system testing and then we have user acceptance testing. Now, system testing checks about the integration about the particular module or a system as a whole. Whereas user acceptance testing tests that whether the system has been developed in accordance with the user specification and the business requirement. So time box system management is a technique which integrates both system and user acceptance testing, but needless to say that it also considers the quality aspects. So an objective is to prevent a project cost overrun and delay from scheduled delivery. The answer should be time box management. Now, and that's the final I am giving you this. That is, if any question comes which says that what are the techniques which can be used for avoiding the project cost overrun and delays, then your answer should be time box management. Next is decision support system. Name itself says if you break this entire, read it carefully, any system which supports decision-making process is decision support system. So when a system is going to support any decision-making process, then it has to be interactive. Interactive in the sense you raise question, what if, and you get the answer for it. So it's basically an what if analysis is also part of decision support system. Why do we need decision support system? Because if it is a structured decision, you know the steps to be followed. But if it is a semi-structured decision, then you require interactive. You take assistance of system to guide you in the process of making decision. Now, what are the characteristics of DSS and what limitations and things it imposes now? DSS supports a semi-structured problem. That is, if there is a definite procedural pattern to be followed to a problem, DSS won't be of any help. But if it is a semi-structured problem, that is, it requires certain inputs and certain decisions, reasoning as well as certain facts to be combined, then it is DSS is a part of it. It is very flexible and adaptable to changing environment and scenario. That's very important. That is, decision support system is slightly flexible because it is not very structured. Had it been structured, it is not going to be flexible and adaptable. But it is very flexible because of the nature that it is semi-structured, and it can it adapts easily to the changing requirements and scenario. I have, in fact, developed one decision support system for an ophthalmologist when I was running my software company. That is, it's a decision support system where it was helping the patients to review their own problems and then finally come up with the diagnosis. Decision support decision tree is used as a questionnaire to lead user through a series of choices until a conclusion is reached. Now, for example, in Western countries, if you go, so now if you consult a doctor and if you are having, every disease has a sequence of, what you call it as symptoms. And so, you take an appointment, you visit the clinic. At the clinic, there are assistant and junior doctors who will assist you, make you sit in front of a system, you go through the questionnaire. And those questionnaire, when you are answering, because certain, you are at the freedom, you're not bothered, you're not embarrassed, you answer those questions, and those questions guide you through a series of choices, and which brings us that is okay, fair enough. Yeah, as per the choices which you have, the questions, answers that you have given to the questions, you are most likely suffering from the following 3 diseases. It is printed on a slip and it goes to the doctor. A doctor doesn't have to, do the routine work, and it has to only focus on look into the exact, more detailed symptoms for those 3 diseases. And accordingly, he decides, according to the symptoms, he decides what the patient is suffering from, right? So that's a part of decision support system. Efficiency versus effectiveness. Now, efficiency has got something to do with the, consumption of resources, and effectiveness has got something to do with the adherence to the compliance. So decision support systems are designed and are less focused on efficiency. As I said, there's a questionnaire that will lead user through a series of choices. Depending on how you answer, will decide how much time you're going to take, right? So some patient may take less time, some patient may take longer duration of time when they're sitting in front of the DSS. So DSS designs are less focused on efficiency. They're not concerned with how much time resource or how much system resources are being consumed, right? But they are more focused on effectiveness, that how accurately the diagnosis will be done. That is, they're more concerned with, right? So this is all about DSS. We move on to the Agile system development methodology. That is, when you're talking about software development, there is a method called Agile system method. Now, Agile means itself very flexible, fast. All these are words. So I always request all of you that if you find any word which is there, you right-click the word, select the word, right-click and go to the synonyms, and you will find that easily you can understand what does the word means, right? So agility refers to writing a program without spending much time on pre-planning documentation. So normally when we start a software project, it happens that you decide, you make a flow chart and you write, all these steps, how you're going to flow of work is going to be done. That's called pre-planning documentation. But in Agile system, we don't do that. So we give less importance on formal paper-based deliverable. That is, I'm not going to maintain a file for it as to what method I'm going to follow. It's just like that. I sit in the front of system and you tell me what you want and I start writing the code. Junior had something like that. These days, you must have heard about it. They're coding programs, 10-year guy sitting in front of the system and making a code and developing an app. Agile development gave preference to producing releasable software in a very short iteration, typically ranging from 4 to 8 weeks. Now, again, as I said, it is very clear. You're not wasting time in planning. You're not wasting time in documentation. You're not wasting time in getting approvals. All you are doing is understanding what the user wants, and accordingly, you are starting working on developing a prototype, which is again, when implemented, will come up with requires lot many improvements. You do that, again, you implement it, you do that. You keep iterating, that is, at a shorter interval of time, and you can develop a software within 4 to 8 weeks. At the end of each iteration, the document that worked well and what could have worked better are considered, along with the identification for improvement to be implemented in subsequent iteration. That means I develop a prototype, implement it. If anything is useful, that is working very well, I'll document it, else I'll ignore it. So the major risk with the agile system development methodology is that only I know as a person what I have done for developing the software. So which means that the major risk is that there's lack of documentation. Suppose if I leave the organizations, everything which I have done for a software goes with me because it is not documented. Prototyping, all you must be very familiar with. Prototyping is a process of creating system through controlled trial and error. Like say, for instance, I have an idea, I have a concept, I wanted to develop that concept. So I wanted to show that concept. So how do I show that? I develop a working model for it. That working model itself is a prototype. It is an early sample or a model to test a concept or a process, as I said earlier. It is a small-scale working system used to test the assumption related to the requirement, program design, or internal logic. You must have seen, if you have watched this Startup India, then you must have seen that most of the entrepreneurs who were there, they were having a prototype that is a sample of their model. And even the sharks were asking that, do you have a prototype for your model or your idea or a concept? And based on that, they were able to get the funding from them. So that's how prototyping is. It is a method of system development that saves a lot of time and cost because you're not going into full-scale production. You're just developing a prototype or a model. Now, prototyping focuses mainly on what the user specification are, and hence there is a potential risk that the finished product might have poor controls. Now, when you are developing a prototype, like say, for instance, I'm developing a prototype on a small aeroplane model, let's say, for instance, or even a drone model, then in that case, it is what I want my drone to do. These are my specifications. As a result, there may be, my model, which is very good as far as functionality is concerned, but maybe at the risk from the aviation point of view. So because I have ignored certain controls, because it is not expected that user to be very clear about what he wants from the prototype, as is at the same time, he's very concerned for the security measures also. Normally, top-up testing method is most effective during the initial phase of prototyping. Now, top-up means that is having a broad view of the entire model and seeing it from that angle. We have now rapid application development. RAD includes small and well-trained development teams. Now, any person cannot be part of the rapid application development program because you require a trained team to be a member for that. That is who are experienced. We make a lot of use of prototypes. There are tools to support modeling, prototyping, and component reusability is an important aspect. There is a central repository, rigid limits on development timeframes. Now, I'll just give you a small example. Rapid application development, if you look into the software development, I'm sure it's not expected, but if you had an idea about it, that's really interesting. When we write program codes, right, you write syntax and you write algorithms. Many times we want a similar set of instructions. They are called as function or subroutines. I have written in the program. So instead of writing each time those program, I create the repository for those small modules or the functions or the methods, and I call them as and when I require for my program. So this is a central repository, and then you have this is the concept of component reusability. Now, software components or objects, these objects are reusable into the programming as and when they are required. Rigid limits on development timeframes. Now, rapid application development, as the name itself says, has a restriction for the time. Now, RAD enables the quick development of systems by reducing development cost and maintaining the quality. Now, rapid application development system is definitely when you are doing, there is a component of reusability, you have a central repository, you work with prototypes, obviously you're going to save cost and, quality will be better. The rapid application and development uses prototype that can be updated continually to meet changes or the user requirement. Now because there is a central repository, you have a system where you can deposit you're keeping the source code. So if there's any changes are required, you can do the changes immediately. Then we move on to object-oriented system development. These are very technical. Unless and until you have a programming background, you'll find it a little difficult. But it's okay, fair enough. There are certain things we should remember. Like in this case, you can find out RAD you can remember that it uses prototypes. There is a component of reusability is there. There is a central repository. It is used for quick development of system. It saves a lot of cost. These are something very basic. Now, object-oriented system development is a programming technique and not a software development methodology. Now, this is basically a programming technique that I have spoken about. Normally, Java and C++, these are the programming languages, they make use of it. I'm familiar with Java, so I can explain it to you. Object is a small piece of program that can be used individually or in combination with the other object. As I have mentioned earlier, I write a program, a piece of a program. That piece of program, I have to be used several times during the entire program. So I make it as an object and store it, and in the central repository, either individually or in combination with the other objects, and I can call that program, method, function as and when I need it. Instead of writing the whole program, those source code lines again. In object-oriented language, applications are made using smaller components. They are called objects, as I've talked about it. Object-oriented uses a technique called encapsulation, in which one object interacts with other object, whereby any particular object may call other object to perform its work. As I mentioned, encapsulation in the sense that functionality of one object is shared with the functionality of the objects belonging to that very object class. So these are technical things. I don't want to go into detail, right? So major benefit of object-oriented development is the reusability of the code. As I have mentioned, this is an important, whether you talk about the RAD or you talk about OOST, it talks only about the reusability. That is, I don't have to write the program source code again and again and make the program lengthy. Now, this was the reason when we have seen that they were talking about, right, when I have spoken about this, remember this function point analysis and source code line code. But if the reusability is there, you'll realize that the size estimation will be very. If I'm estimating the size of my software, it could be very less, because the number of lines of codes will be less, because each time I would require to call a function or an object or a method, I'll just give a reference to it, and central repository set will be called, used, and it will be put back again. But function point analysis, though it is indirect method, but it will help me in estimating the size of the software very realistically. So was the reason that I have spoken that function point analysis is more reliable than source line of code, because source line of code is a smart programmer is there. Instead of writing a bulky program, he or she can write a program which is very smartly written, right? So we did all this. I think these are the two things which are also you should remember. One is software re-engineering and the other is the reverse re-engineering, sorry. Now, re-engineering is the process of updating an existing system by extracting and reusing design and program components. Now, re-engineering, like say, for instance, if I have a big table, I can dismantle the table and I can again extract portions of the table to make it a small table and a stool, right? So I'm doing re-engineering. So it is again a process of updating an existing. When there's an existing system, I'm trying to update that. I extract and reuse the design and program components, right? I know the program components, the objects, I can use them. But in reverse engineering, it is the process of studying and analyzing an application and then information used to develop a similar system. Now, reverse engineering is that I understand that how the things are working for a particular application. I analyze it, how it must have been developed. And then based on that information, I try to develop another similar system with a slightly different functionality. So with this, we have come to the end of the part 2 of Information System Audit Module 3. In the part first, you have done online auditing techniques, testing in SD system development lifecycle, check digit parity, checksum, and cyclic redundancy checks. And now we have completed Pert, CPM, Gantt charts, functional point analysis, EBA time box, decision support system, agile system development methodology, object-oriented system development, prototype, and rapid application development. With this, we have come to an end of this module. Soon I'll be uploading the practice question with their explanations. I hope you're finding these sessions helpful. Do share your feedback at my YouTube channel. And if you're liking this initiative and appreciating it, that what I'm doing it, then I sincerely request that please do share in your peer network so that the rest of other fellow colleagues and professionals can be benefited. And if you like this, the way I'm doing this work, so please do like and subscribe my YouTube channel. Thank you very much for your patience listening.